Today we'll be going over rational graphing, and we'll talk about vertical and horizontal asymptotes. So moving on to vertical asymptotes. Vertical asymptotes is where a graph approaches a x value but will never reach the value. We'll need to look at the denominator and we'll find what x value will equal 0. The graph will never be able to be this x value because we can't divide by 0. Looking at this one, we need to look at the denominator, which is the x plus 4, x minus 2. And so in this case, we'll have two asymptotes. And we'll set each one of these to equal 0. And so for x plus 4, we'll have an asymptote at x equals negative 4. Of course, we're going to subtract 4 to both sides. And for x minus 2, we'll add 2 to both sides, giving me x equals 2. So my asymptotes will be at x equals negative 4 and 2. Looking at our graph of our function, you may notice that we have two holes or asymptotes where our y values are approaching negative 4 and 2, which we expected and predicted. And drawing those two lines, you may see that our graphs will never touch it. When we get very, very close, you can zoom in at a very large number to see how close we are, but we'll never reach the value negative 4 or positive 2. Looking at the horizontal asymptote is where the graph approaches a y value. We will call this a limit, but we'll never reach it. There are three rules for this. If the numerator has the greater exponent, then the limit goes to infinity. What that means is if our power on top is greater than our powers on bottom, then it'll go to infinity. If the denominator has the greater exponent, so the exponent is greater on the bottom, then the limit goes to 0. If the exponent is the same, then we can find the limit, and also each one of those. Looking at the first case where we have the exponents greater on the top, notice we have 3x squared compared to 8x. Well, clearly 2 is greater than 1, so we'll have our limit approaching infinity. So if we set f of x, we would say limit of f of x as x approaches infinity. This would also go into infinity. Now, I will not require you to write this out, but it is good to already have an idea of how we would write that. And so looking at the graph, we'll look at case 1, which is the green one. And notice that as our x increases, our y is increasing, and as our x decreases, our y is decreasing. So as we zoom out, clearly this is going to infinity. For case 2, we'll look at when the bottom is greater. And notice here we have 8x cubed on the bottom versus 3x squared. So all I'm doing is really looking at the exponents, which one is bigger. Okay, and so in this case, the limit of f of x, I'm calling this f of x again, as x goes to infinity, will go to 0. And coming back to the graph, we'll look at this, and we'll look at case 2, and notice as we zoom out, our graph is going to 0. Okay, so it should be easy to see. We'll do an easier one to look at, and again it goes to 0 very quickly. Okay. The last case we'll look at is when we have the same exponent on top and bottom. So we have x squared, x squared. Okay, and so we can think of it as x gets extremely large. We'll say 1,000,000 squared. Well, clearly that plus 1 is not going to affect it anymore. So what we're going to do is we're going to take it and get rid of anything past the x squares. Okay, so we'll have 3x squared over 4x squared. Then we reduce the x squared out, and so this limit, again we're going to call this f of x, as f of x, so limit of f of x as x approaches infinity will equal 3/4. And so looking at case 3 graph again, we'll highlight 3/4 with the green, and notice you can only see right there but clearly this graph is approaching it. As I zoom in, you'll start noticing a difference in it. So the purple will approach the green. As far as my computer is concerned, it will look like it's approaching, touching it, but really it's just getting closer and closer. The last term we'll talk about is holes. This happens when both the numerator and denominator both equal 0. So if you go back to the vertical asymptote, we find when the bottom one equals 0, well, here we have both the top and bottom having x plus 4. And so what that means is one of my asymptotes is at x equals negative 4, but we can also cross this out. So the graph is going to look like, if I had x plus 3 only, but x in this case cannot equal negative 4 because we would be dividing by 0. And so as we come up to the graph again, we'll look at this graph. We'll look at this graph, and again, if we have x plus 3, it's almost exactly the same. But notice on my table, negative 4 is undefined.